which now is divided in a few different countries, and influence of culture is easy to see in each place. But what is interesting, it is mind-boggling when he's a president of town. Previously, it is in Russian style. It is looking like here, but in 18th and 19th century, Częstochowa was a place when industry started grow. Here is interesting equipment because it is a matching machine equipment which preparing matches from wood and sulfur, utilizing only mechanical solution without electronic. And it is interesting that it's still working. And Częstochowa, sometimes people told that it is a spiritual capital of Poland because we have a special monastery. It is a so-called Black Madonna Monastery, which people came by foot pilgrim in 16th of August by foot to Częstochowa from different place. 500 trip, it is no problem for some people. They walking 1 month. And our climate is quite different in compared to Andhra Pradesh, especially in Tamil Nadu, but looking like in Himalaya. It is a picture maybe 15 years ago make when I traveling and have some problem with snow. Here is a typical picture from my window. And I'm working on John Długosz University, which was established in 1971. And it is one of biggest university in such part of Poland. We have some strong universities in south and in north. When it is town Łódź, it is a ship, but it is in the water name, because sometimes when you translated a name directly, some joke maybe. And we have some faculties. I working in Faculty of Science and Technology, but it is a Faculty of Health Science. Now it is we teach medical doctor, and Faculty of Law and Economics recently was established. But in my opinion, it is very good because science, our department also collaborate with Faculty of Health Science, give a joint project, and it is very interesting for university. We have a very good team in Department of International Collaboration. It is a young team open for world, and invited some PhD and master students. We have several programs. It is also programs Erasmus Plus, and I hope I try to establish a collaboration in the frame of such program between NIT Warangal and my university, which give opportunity for, I'm joking, not without expenses exchange program, because European community pay for such, and it is very good for start collaboration, because a teacher obtain money for 1 week stay, but for students and PhD students maybe up to 1 year of 1 semester, and also it's possible, for example, 1 month stay for perform a specific calculation. Such presentation was prepared with collaboration with my colleague, Professor Brick. He is a member also my team, but he working like quantum particle. He is diffuse in different places, but he is a worldwide expert on luminescence. When somebody of you try to publish article in optical materials, probably his manuscript or her manuscript pass on his hands. And I'm endeared him to help in preparing such presentation. And we start from explain why, in which way we can use a phosphor for solid state lighting. And next, I recall information about possible ways of getting white light. I told next why red phosphor is important element of white LEDs, and it is maybe a little bit the difficult part about some spectroscopic properties of a special kind manganium 4+, because manganium is very useful element for lighting, and it will be appear in many my talks during such stay, because in nowadays is very important for spectroscopic interest. And I told how we use such 4+ ions for applied as active element in phosphor, and a little bit focus on emission spectra, depending of matrix which is a member, and at end will be concluding remarks. And phosphor for lighting. As we remember, during centuries, people like to elongate a day. And it was a many solution, but such solution and new source of light were connected with discoveries in physics. Physics is a mother of lighting, because for example, when we recall typical electrical lamps, when we use a wolfram, efficiency is 4%. 4% of energy is exchanged on light, but 96 for heating. It is not good. And next was discovered fluorescent lamp. You remember some experiment in end of 19th century and start of 19th century, when people have interest regarding conducting current across ionizing gases. And 30 years ago was discovered lead, but such lead are still improved to obtain end of our investigation on lead, when we obtain a light is the identical like sunlight, because you see that it is not not looking the same like sun. It is a better irradiation here. And it is a photo from satellite when is combined, yes, in not make in the same time, but it show how much energy we use for lighting. And for example, when efficiency of diodes, for example, will be not 4% like traditional bubble, and for example 24, it is a 6 times energy less, and it is a huge energy which for many years was used for lighting. And what is important parameters of light? It is a color correlated temperature. When there is the temperature of ideal black body radiator, and it is most important, one of important parameters which describe quality of light and visibility of utilizing such light. And next parameter is a color rendering index. It is a show how our device is similar to white to sunlight, because we don't know if sunlight is ideal, but during evolution we think we not know better. And ideal is color rendering index 100. It is the best light which is the same like light of sun. How we make white light? It is possible like in painting or television, for example, first color television. We should mix 3 colors, red, green, blue. And as results we obtain white. But what we can do, for example, is several ways to utilizing luminescence for generating white light. It is many so-called elements which may be working as a luminescence center. For many years was only some lanthanides. Yes, okay, it is such elements which generating different in different spectral range. and also it was dependent of matrix. And here we have some information regarding emission spectra, different kind of lantanadas. And here is a short description in which spectral range each of elements may be emitting radiation. And also interesting that some transition metal ions also be a source of light when particular ion will be embedded in matrix, because when we talking about materials emitters, we should take account two or compare two elements. One is a so-called active element source of luminescence, and second, also important, is a matrix, because without matrix is lighting is difficult. And also is many elements able to emit radiation. But we focus generally on few elements, manganium, chromium, which emitting in red spectral range. It is up to almost end of range when we able to see such a color, yes, because human eyes able to absorb radiation between 400 and 700 circa nanometers. Yes, and it is information which may be very easy. How to design luminescence or lasing materials. For first, necessary determining a spectral range when we are interested. If we need, for example, for agriculture, improving, we need a special kind of red. When we need for indicator green, we need a different materials, blue also. And at first we should choose a luminescence center. It is maybe lanthanides or transition metal. A second, proper matrix. Matrix is also important for lighting, because when luminescence center is embedded into matrix, they interact and transport energy between absorbing light and or another kind of energy, and next emit. It was not so easy, because when we combine two elements, matrix and luminescence center, we should take account many so-called technical reasons. It is doping ion radius, because you know that you're able to synthesize some kind of materials, not all combination exist. And also may be interesting when we pumping, it is necessary to have a very convenient source of pumping light. Yes, also resistance for influence environment. And for example, when we have materials, typical is halide materials, it is not water resistant and some environment resistance, and even air may be destroying such kind of materials. But we have many good matrix from theoretical point of view, but is not useful from application for point of view. And another topics which we should take account. Why people looking for another elements like lanthanides? You know that most countries, even like India and USA and European countries, not have a source of such elements. It is mostly is located in China, and like lithium for battery. And it is also from economical point of view and from also political point of view is important when we not only depend from one supplier. It is now when somebody have information from people which working in business, they know, and I have only one source, it is dangerous, because he told stop and I have a great problem. Now it's also similar situation with a battery, when suppliers of lithium think we not sold you lithium. We grow a joint factory, you give money, you give technology, I give materials, and we will be divide profits. But it is a dangerous situation, not only in science, but also in business. And here we go to next step. How to practically make white light? It is possible. We can, for example, thinking, such element give a blue light, such element give green light, such element give red light. We put in one matrix such elements and obtain as results a white light. Is many example when people do it. It is one way of obtain a source of light. Especially, I am invited in by department when in name is glass. Yes, and you know that most of glasses is very sensitive for embedding some elements and give more opportunities to mixing as such are easy in production, but also is very stable. And for example, when we put such pieces of phosphorus materials in water and in high temperature and sometimes in acid, it is not destroying them, because a glass have a very strong structure, except halcogenide glasses, for example, glasses with contain another elements. And such materials are very very interesting. Is idea, it is one topic when people working for special application, such materials are interested. But we can also take or go another way. it was discovered 30 years ago, effect of electrically stimulated radiation. Yes, it is a diode, so-called luminescence diode. It is very easy to understand phenomenon, but for many years was difficult from application point of view. When I was in your age, it was a joke that most discoveries in science is in USA, but most application as such discoveries in Japan. And USA government buy money for science. You know how much money recently was lost from government by Harvard, one university. It is a huge money, but profits have a engineer from Japan. And next was Korea, and it is from east to west very slowly going. And now is India also. It is from such point of view very interesting because now in science we have some problems with, for example, patenting results. It is especially when you are a student of Institute of Technology, you should remember that sometimes discovery is connected with a possible future profit. For example, you remember a man which named Konrad Röntgen from X-ray. He asked government to give him additional money to buy a new equipment because all Nobel Prize money he put in to improving his equipment. And he did as a very pure person, but when he patented it, he will be maybe like Gates now or another people. Yes, it is a problem, and it is also important from so-called moral point of view what we do with science. But now also in USA they are focused and many discoveries is not broadcasted before obtain a patent. And here we have 3 ways how do it white light. It is a first, most easy. We have 3 diodes which broadcasting different color. And second, we have UV LED and phosphorus, which was activating by such LED. And we have a blue color from such UV chip, and have additional RGB phosphor, which give us white light. What is the problem in such? You remember that some years ago we see that such diodes give a more blue light, but it was maybe not comforting, but it was also dangerous, because except blue was UV, part of UV, which destroying skin, which destroying eyes. But it is very dangerous. I have such similar what is experience because when I was a student, we make some experiments in the laboratory, but some scientists preparing UV lamps for experiment. It was necessary that they should working a few hours to stabilize level of radiation. And what's happened? We not feel, but after 3 hours in laboratory, we looking like get out from solarium, yes? Was burnet and ice problem. It is dangerous because we obtain one European projects, my group, to eliminate such radiation from spectrum of white light. It is also important to, when, for example, you choose as such. Why was the reason? Because people like to obtain strong light, yes? Strong light is very good, but when strong light should be very good, it was necessary put here a strong UV radiation to strongly interact with phosphor. Now it is some new methods is applied, new technology. It is blue LED with yellow or red phosphor. And when we have a strong emission of red or orange phosphor, we not need a strong power of UV chip, and light is more close sunlight and is more safety for humans. Yes, here is some advantages and disadvantages of such method, which I told. It is now the best solution. We can choose only the very good solution which give the best light. It is more close to sunlight without dangerous UV radiation. Here is idea of preparation light when we use UV chip and some phosphor which is activated transition metal ions. And here is the most important and well-known phosphorus materials. It is activated by cerium 3+. It is not difficult to find or buy element in opposite to rare earths, but give good results. Yes, and to improve a quality of such light, it will be necessary to add some red or red-orange phosphor to improve a quality of such LED. And many years ago, I also put some small input to solve such problem, and we use samarium ions and very complicated matrix to generate orange color for application in LEDs. And here is our achievements, which is published at spectrum emission in visible spectral range, and also in CA graph we show that we obtain a quite good quality of light. And it is very important topic to obtain excellent source of light, white diode, because you know it is connected with a grid money. We use a huge number of source of light, and who obtain a cheap and very good product, he earn money. Yes, it is, because unfortunately you should remember that money and profits is unfortunately one of most important results of human activity. And here you see how much papers was published when people focused on discovery or improve high quality red phosphor. And it was very fastly increasing, and it is connected with money, because it is money or huge money for science is from industry, not only from governments for university. Yes, it is some project. Among them, a most important element is manganum. Manganum 2 and manganum 4. It is a most important element. Is also huge number of papers which published in last few years. And manganum is 4 is metallic, and we should understand some electronic structure to well understand why such materials is interesting for such application. Here we have some information regarding electronic configuration, because in such material, I'm sorry, such materials we have split in electric with electric field from crystal environment. We can split particular levels, and depend of matrix we can obtain interesting as radiation, and with high intensity. And here is some information regarding electronic structure and some energy levels. You obtain such presentation, and you can read it detailedly. And such energy levels useful for red radiation. It is so-called lower energy levels, and such levels may be described by so-called RASA parameters, but for our application it is not most important, but most important is information that depending of environment, depending of matrix, we have opportunity to change value of splitting a particular reverse. You know that in electrical field, particular layers may be splitting, and depending of depending of intensity of or value crystal field, we can managing value of splitting and influence on radiation, because we can managing level of exciting state or level of ground state. It is important, and here we have some energy levels splitting depend of environmental matrix. Yes, it is important, and here we see that when we have optimal crystal field, we can obtain a desired radiation. And what is important for such ions when we find a good or proper matrix? It is that such ions have efficient absorption, because it's important when we put radiation on phosphor, he broadcasts red radiation. We should have a typical source of excitation. And when we should also adopt, when you remember, when we have a blue chip and put on top phosphor, and it is necessary to fully use energy of chip to transform during phosphor into a red line. Second is a possibility do a different matrix managing emission between, it is from experiment from 670 up to 720 nanometers. We have managing emission. It is a color of emission utilizing different matrix. It is my topic and my problem to solve. How choose a proper matrix? Because as you see, it is such spectral range about I talk. It is from 612 up to 700. We not able to see as such because it is infrared. And it is also interesting that we can managing managing a position of red peak to adjusting them to obtain a good correlation with a light of sun, because we can managing in two things. One is a position of peak, but the second is intensity. It is important to mixing such color to obtain a good light. And for example, when we have a very efficient red phosphor, we not need too much blue energy, and we have a more white light, yes, not blue. Yes, and examples of phosphor. I told you about a phosphor which we use rare elements, but also is some discovered phosphor during last few years, which focused on utilizing manganium 4. And such materials possess very complicated structure, but finally emitting a good red line and in white spectrum, because you see that such red line, right emission from such phosphor cover all spectrum above 600 nanometers, and is more than previously people expect. And here is some example of manganium in such strontium aluminide oxide phosphor for white plate manufacturing, because we can predict some details, but when we predict when it is such matrix is good, it is necessary to know what is optimal concentration, but how much such phosphor should be mixed with such chip. But during several experiments and managing composition, it is only manganium concentration, but also volume of phosphor in compared to green phosphor, we can obtain interesting as light. And here is information regarding behavior of manganium 4 ions in various host matrix. And here also you can find what is behavior of manganium in oxide and fluoride matrix, because fluoride matrix is maybe sometimes more efficient, but maybe not stable in environment and high temperature. And for experimental, for people which working in experiment, sometimes information regarding behavior of systematic work regarding behavior of ion in different matrix may give opportunity to use artificial intelligence, machine learning, to found a new or most convenient phosphor and combination, because such equipment only working on basis. Looking such parameters should be very interesting. And for example, we should choose several parameters which describe a good phosphorus. And we should looking for 100, 200 different compounds when in literature is detailed investigate to choose optimal, because such investigation utilizing artificial intelligence and machine learning give us opportunity. And my colleague, which I told about, is a hard-working person and make some review articles when he collect data of such yarn. It is and each article is maybe 100, 200 phosphor investigate for find a direction for next improving of materials. And also we perform some results of such investigation for materials for red lighting, and during our yields some groups investigate some looking for more efficient materials. You see some information regarding some properties. It is a few pages in manuscript when such data collect. And now we have a project in which we collect such data in special kind of databases to help not our mind but electronic processors to choose or show the best solution. And here is some also prediction of best phosphor utilizing quantum chemistry calculation. We for many years also investigate such materials in our group utilizing ab initio calculation, because it is sometimes very complicated. We use many sophistical methods when somebody like to interest such topics. We from time to time broadcasting information that we looking for a PhD student or postdoc to help with such investigation. And here is also based on our quantum chemistry calculation information regarding expectation of optimal crystal field. It is not only strength but also configuration to obtain efficient radiation. And here is some theoretical yields which resulting find a direction how improving phosphor properties to obtain ideal phosphor materials for red lighting. And as we told, we summary for my talk and such place, and we can tune a proper red emission by utilizing proper composition of matrix. It is not only chemical composition but also structure. It is also important information when we make chemical compounds. Manganium may be occupied a different crystallographic position, and each position have a different oxidation level and different crystallographic environment. And except such information which we able to convey to people from experiment, they also should take account such disadvantages of chemistry when they grow materials. And we also told about it, about local symmetry, which symmetry will be most convenient for lighting, and here is some information regarding deformation, because we, during a process of preparation, sometimes we can intentionally introduce some defects in structure which yielding deformations structure and finally give a better emitting properties. Also, it will be in next talk, but it is a pressure effect, because it will be in next my talk. When we compress materials, we change a distance between elements. But with change distance, we also strongly influence on crystal field. Sometimes we able to change environmental, crystal environmental of materials, but also maybe in tutorial I told how you can conserve or stabilize pressure effect utilizing so-called chemical pressure. And here is some example of different kind of material and explanation why as the same ion in different or but similar matrix have a bad or good radiation. Yes, and here is also detailed explanation why in such similar structure possess different emission properties. And we calculate also and able to predict new materials for desired application, for particular phosphor. And here is some conclusion of my talk. When why we can choose and why is a reason to choose manganium 4 as active element for red phosphor. I told why red phosphor is important for lifting, and also we able to predict properties up to present non-synthesized materials to earn money and time of experimentators which not should synthesis unperspective materials. And I also could recommend a book of Professor Brick. He collected his knowledge regarding phosphors, and it is easy to obtain as a book and probably in library maybe, but I think that from time to time is easy to pick up from web. but I hope that such my first lecture give you knowledge how science working. But science is not only science, but also is connected with environment, especially when our activity should be applied for improving comfort of life. It is not a joke, because when I obtain money from our government or from scientific project, I must for one page justify why my science not be never employed or applied, because project is a fundamental science. It is crazy because, for example, in USA, you must start what for you, what is idea and will be applied, except maybe some relativistic physics or fundamental science, but it's mostly is not so good. Yes, and thank you for your participating here, and I hope that next lecture will be not so heavy like it. Thank you. Maybe next time.
Thank you, Professor Rasim sir, for organizing. And thanks for the wonderful lecture, Professor Michael. And can you please tell, when we compare with the commercially available semiconductor materials that are required for exciting these phosphor materials, what is the hindrance we have? Because you are an expert in this area. Not all the, nowadays we are replacing towards LEDs, and we are also studying about phosphor in glasses. Sir is expert in glass, and we are phosphors embedded in glasses are also coming into picture now to improve the device performance. So can you please tell what will be the next, how to go for energy efficient materials? The thermal instabilities are happening due to the long time exposure. The blackening effect around the devices are coming. So can you please share your views on that? Thank you.
Yes, it is two problems. One is durability of term of using a particular phosphor. Yes, it is a problem because some most efficient phosphors decreasing properties for short time. Yes, and some exist in, for example, fluorides. They exist only in a laboratory because I not expect that any company utilizing such phosphor, and after a few days, several days, and from beautiful light we obtain dark or blue light. It is a great problem. Second problem is connected with expenses, with price for final product. It is also a great problem because we know solution, and it is well known. For example, my colleague Professor Brick collaborate with Samsung. That is a big company, and also with LG. And they not applied many solutions because they told that very good product, but maybe or expensive or application synthesis technology in macro scale in production is difficult or give not repeat quality when you have it. It is some advantages of science, I think, when we find such materials, but it is also difficult like in life, when you should be young, rich, and in good health. It is very difficult, especially people are rich when is old and not beauty. It's unfortunately. And here is also the same situation, that science and scientific achievements, it is one topic, but a second is market and industry. It is should collaborate, but sometimes engineers or managers should take a decision which is optimal for a company, not optimal, for example, taking account only quality of products. No, thank you.
Good afternoon, sir. My question was only that what did you mean by matrices when you very firstly mentioned designing luminescence or lasing materials? We first started with determining the spectral range, and then we got down to two outputs, which was luminescence, and the next was a proper matrix. So what is the proper matrix in that?
Yeah.
Matrix.
Yes.
What is the importance of matrix?
Yes, I told that matrix is very important, because this matrix is one of most important parameters. Second parameters is optimal doping, because it is connected. I show in next lecture how is influence both, because for example, sometimes when you predict excellent matrix, and when you try to synthesize materials, sometimes it is impossible from, for example, chemical point of view. It is atomic radius not give a substitution, or it is not equivalent position in atomic, which is occupied by the ion. And for example, in one place is one ion is 4 plus, in second maybe 3 plus or 2 plus, or maybe the same ion but in different crystal environment symmetry. And it is also bad influence on materials. Second problem is window of transparency. When we put, for example, a strong irradiation, some radiation, you know that some radiation is absorbed by materials. What does it mean is absorbed? And when it is maybe connected with enhancing temperature. When we enhancing temperature, we decreasing luminescence intensity. It's many problems to solve. But I told in my picture that it is we should choose proper elements, activate element, it is luminescence center, and matrix, but it is only start. And like we told, in details is a great problem, especially instability, when you know such LED, it is sometimes working in high temperature. It is One is electrical resistivity, because we exchange current into light. But second is radiation processes, because such UV chip also produce a huge energy, and such energy is partially converted into light, but mostly in heat. And it is also problem how materials, what is a material's behavior in high temperature. It is a topic when we discuss 2 weeks, and we not good solution. But I thought recently we obtained a very good tool as machine learning, because it is what is it? It is not thinking, but a system working like we ask them, and he choose parameters. Sometimes we obtain a solution which not exists, like you solve equation. Yes, sometimes it is irrational results. Yes, for example, mass less than 0. Yes, and it is a good solution because math of that. But here is also the same situation, that artificial intelligence give us results, but we should looking it is real to make. For example, because they looking in such materials was, for example, heat transfer rate is very good, but here band gap is here, and he mix such results and show that such materials should be the best, taking account bias. We add some new information from new papers, it may be changing, but it is some advice, not results. Without human mind, we not solve such problem. But people still working. It's difficult to told in science never or is impossible. Maybe in when I told about superconductivity, I told or recall to you my story that my director of institute told it, no, the subject is impossible. When superconductivity will be in above 30 centigrade, I have a cactus on hand, and when we'll be in non-metal, I will be working on the opposite. And after 3 months, it was a discovery of high temperature superconductivity, and it is a many situation like here, and people working on improving bubble lighting, yes, and wolfram we exchange on maybe another materials, and they in laboratory obtain efficiency 5%. Maybe it is above 25% better when ordinary, but in compared to that, it is maybe for a particular application it will be useful, but mostly no. And is future in your hands, not in mine. You should base it on our knowledge, introduce a new idea, and don't worry when 5 will be no results. At 6 will be better. Okay, it is for yes, okay.
Any other question? No more questions. Then I'll conclude this. Thank you, sir. Thank you. Very nice and interesting lecture. So I participants, right? And then participate in all the lectures. So don't in lectures whatever you have given to you. And is also very, very important. So if you read certificates, all them in lectures. So the post lunch start exactly o'clock here. 2 is a lunch. So lunch will be I have seen, I think most of you, you went today morning also, the same place, same venue. You will be served lunch, right? So there is a vehicle, electrical vehicle, I mean, in the ground floor in front of the seminar complex. You can make use of the facility and directly go to the mess, finish your lunch, be here sharp by 2 o'clock. The session will try to start. Already you are late by 1 hour. Okay, thank you.